Our today's topic of discussion is introduction to modern electric drives. The system which are employed for motion control is called as drives. It can be a mechanical drive or it can be a electrical drive. So our topic of discussion is uh, going towards the electric drives only. So these are the contents of the presentation. Here we will discuss about the basics of drives, that is, then the advantages, disadvantages, the various applications of the drives, etc. Then we are going to cover, in this case, the software which can be used to simulate the drives before its actual implementation. Then the opportunities in the field, or whatever the career paths you can go ahead with this particular knowledge. In case of the application, the main application, if I say, that is in case of electric drives, is electric vehicles. So you can think of the big domain which is going to open in front of you with the help of electric drives. Okay. So when we say electric drives, in large number of industrial and domestic applications such as rolling mills, transport systems, machine tools, fans, pumps, or washing machines, etc., the motion control is needed. The picture which shows that in case of the traction system, that is electric vehicles, the electric drives are mainly being used. So in this particular webinar, we are going to discuss about what are the drives and what they can be used. So the system which are employed for the motion controlled are known as the drive. In that case, the different prime movers, such as you may say the diesel engine, steam turbine, or the electric motor, may be used for that particular motion control. But in that case, when the electric motor is basically used for the motion control, we called it as the electric drive. So in other words, you can say a drive is a combination of various systems combined together for the purpose of motion control. Okay. The picture uh, shows that uh, the ABB drives. There are various big companies like ABB, Crompton Greaves, Danfoss are the leading manufacturers of the drives. The ABB drive you can see in the picture. What is inside of this particular box, or the black box you can say, will be explained in this presentation. So this block is responsible for the motion control. Okay. So in short, till now, whatever we have discussed, you should be able to understand the definition of electric drives, that the drives are systems which are employed basically for the motion control, which requires the prime movers. And in case of that prime movers, if they employ electric motor as the prime mover, then you will be calling it as an electric drive. Okay. These are the basic components of electric drive system. Okay. It has 5 main functional blocks, namely power source, power modulator, motor, mechanical load, and the controller. The controller is the combination of the sensing unit and the control unit. So in that case, for example, if you want to control a DC motor and you have AC supply with you, so in that case, you will require a converter which will convert AC into the DC. In that case, the rectifier will come into picture, and that in that case, this power electronic converter or the power modulator will be your rectifier. As we are talking about the speed control of the DC motor in that case, so we will require the speed sensors. The sensing unit will be your speed sensor. And in this particular closed loop control scheme, the digital controller, or there may be analog controller also, the control unit can be the PI controller, PD controller, PID controller. PI stands for proportional integral controller, proportional derivative controller, or proportional integral derivative controller, which will actuate the error. We will be discussing all those things in the coming slides. Okay, so before going towards the modern electric drives, let's go with a small discussion about the conventional electric drives. Here in this case, we are controlling this DC motor with the help of two more motors, that is the DC generator and AC motor. What we want, that we want to control the speed of this DC motor, so that's why we are using AC motor. We are controlling this AC motor, and as per that, the shaft of this DC generator will going to rotate, and the generated DC supply we are going to give to the DC motor, and then accordingly the load will work. So such kind of uh, drive system we have seen, means if before you have read about this particular topics, then you may know about the Ward-Leonard scheme. In that case, they were using the two DC motor, one DC motor and one DC generator for controlling one particular DC motor. So what we find in this particular case, the system is very bulky, the system is inefficient, and the system is not that much flexible. Okay, because for controlling one single motor, two more motors we are going to use. Okay, also the system will be very noisy, because if you have seen the DC motor in the running condition, so in that case you can say the system will be very noisy. Okay, so in case of the modern electric drives, with the advent of power electronics, we could able to come up with the modern electric drives. In this system, you can see the conversion of the power can be possible with the help of this power processor or power electronic converter. So that's why the system is small, the system is efficient, and the system is flexible. Okay, so this particular scheme is the closed loop control scheme. Okay, and this control unit can be means you may use the PI, PID, or PD controller, but that control unit can be designed with the help of the microcontroller, can be designed with the help of digital signal processor, or the FPGA, or the PLCs. Okay, so if you want to improve this modern electric drives, in that case we can go ahead with the changes in the power source. For example, we are considering about the electric vehicle, and when we are why we are using the electric vehicle, because the pollution is the main aspect, and for that the power source which is coming from the grid is polluting the environment. So that's why you may go ahead with the renewable energy sources. Then in case of the control parameters, one may go ahead with the power factor correction, power electronic converters, the non-linear control strategies can be used, the real-time control strategies can be used, the DSP can be applied in while using that controller. Also, there can be the speed sensorless technologies are there, and people are working on the machine design and machine theory to improve the machines. So when, if you want that the efficient drive system are to be there, then one should think of the efficiency of each and every component, that is efficiency of power source, efficiency of power electronic converter, efficiency of the controller, efficiency of the sensor, efficiency of the motor. Then and then the efficient modern electric drives can be there. So in that case, let's discuss one by one what are the components are there. So the first component which required in the most important in case of the electric drive, because I have said already, the heart of the electric drive is the motor, because if the motor is being used for the motion control, then and then we are going to call it as the electric drive. So the motor is used for the particular application will be selected by taking into account the different factors, like the cost one will be the one of the parameter, the level of power will be the one of the parameter, and the performance required by the load during steady state or the dynamic operation. Steady state means the condition when it will be at running smoothly, and at the dynamic means when at the starting point or when the load is being increased. In that case, according to means as per the particular application, what do you require, accordingly you are going to use or you are going to select the motor. So in case of the DC motors, there can be the DC shunt motors, like when the shunt field is in parallel with the armature. Then there may be a series DC motor when this field is in series with the armature, or there can be the compound motors like short shunt and long shunt. Okay, so in that case, this if someone is using this DC motor, then availability of the power source and then the different components can be selected. Okay, so if you require the more torque, then you may go ahead with the DC series motor. And if the torque requirement is not that much, then the DC shunt motors are being used. But in the today's era, the DC motors are being used only for the specialized applications, because they are having different disadvantages, like commutators are there, the brushes need to be replaced, the maintenance issues. So that's why the people are going ahead with the AC motors, like induction motors, permanent magnet synchronous motors, brushless DC motors, stepper motors, etc. Also, the people were using the BLDC motors in the electric vehicles in most of the cases. But as there in an Indian scenario, if you may say, there is less earth electromagnet, less permanent magnet is available, or no, I can say there is no availability of the permanent magnet. So that's why in Indian scenario, the induction motor is better than that of the BLDC motor in case of the electric vehicles. Okay, so the motor is most important thing. According to the motors, if whatever the motor you are going to use, accordingly the and availability of the power source can be selected. Then whether you are going for the position control, whether you are going for the torque control, whether you are going for the speed control, the different sensors are required. And the basic two types, that is AC motor drives and DC motor drives, are there. So which particular motor you are going to use, based on that type of drives are being created. Okay, then the next thing comes into that five main functional blocks which I have told, out of which the power source is there. The power source supplies the required power or required form of the energy. It can be AC or it can be a DC. In case of the AC, it can be a single phase AC or three phase AC. Different frequency ranges can be there. We generally use 50 hertz, and the other countries they are using 60 hertz. There can be low or medium power rating. There can be high power rating like 3.3 kV, 6.6 kV, 11 kV, etc. In case of the traction, we go ahead with the 25 kV single phase 50 hertz. For aircraft, we require the 400 hertz supply. For underground traction, we require 500 to 750 volt DC. The Igatpuri, the Mumbai line in the Western India, was 1500 volt DC. Now they converted into the AC. In case of the DC, there can be the different batteries like 6 volt, 12 volt, 24 volt, 48 volt, 110 volt, etc. The batteries are being used in the electric vehicles mostly. So in that case, the power source and the motor, which particular motor you are going to use and what is the availability of the power. Based on that, you need to select an power modulator, which will modulate the power from one part or one type to the another. Okay, so in that case, the converter we require. The converter is an interface between the motor and the power source. It provides us the adjustable voltage, adjustable current, and frequency. So in that case, the main function of the converter is to convert an electric power to the form that that the motor can use. For example, let's say we have the electric vehicle. That is, in that case, we are using the BLDC or DC series motor, let's say, or we may say the induction motor we are using. So in that case, we require an inverter, which is going to convert DC into AC. Okay, so the power modulator is most important. Without the advent of the power electronics, it was not possible to think of the modern electric drives. Okay, so the power modulators can be of 5 different types. It can be AC to DC converter, that is, we may say rectifier. Then DC to AC converter, that is inverter. Then AC to AC converter, that is regulator. DC to DC converter, choppers, and AC to AC converters, cycloconverters. Let's discuss that. If we have the output side, the DC supply is required. That is, motor can be let's say DC motor or the BLDC motor. In that case, we require that we may use the converter. So that rectifier can be controlled rectifier or uncontrolled rectifier. In case of the availability of the power source as the DC, availability of the power source as the DC means battery is available, and we are going to control the AC motor, maybe an induction motor, permanent magnet, synchronous motor. So in that case, to control it, we require the inverter. Okay, of the mechanical loading or whatever the availability of the power source is independent of the controller used. You may select or you may go ahead with the analog controller. Previously, we go ahead with that, but right now, with the advent of more computing power, the people are going with the digital controllers. Whatever the difficulties we were facing with the digital controllers are nullified, and that's why even though we are considering small disadvantage, still the digital controllers are better, because in case of the digital controllers, if you want to change something, then you can change the algorithm. That algorithm can be PI algorithm, that algorithm can be PD algorithm, that algorithm can be PID algorithm, or the hysteresis, bipolar hysteresis, or whatever the advanced technologies you want to implement with the help of digital controller is possible easily. In case of the analog controller, you need to change each and every component to meet the requirements. So that's why I suggest that the one should go ahead with the digital controllers. Okay, for example, for the semiconductor converter, the control unit is the firing circuit. In that case, the for that firing, the different mechanism or different switching patterns we can use. That can be PWM, that is pulse width modulated, SV to PWM, or SPWM can be used. Also, the PLCs are used as the control units. Not only PLCs, you may go ahead with the microcontroller, you may go ahead with the Arduino if you are comfortable with it. The generally people right now are using the DSPs in many of the things. Also, the FPGAs, that is field programmable gate arrays, are people being used in case of the control unit to create the controllers. Also, in case of the sensors, means whatever the requirement, means you may go ahead with the speed sensors, torque sensors, position sensors. In that case, the current and voltage sensors are also required, through which the control can be possible. And in some of the cases, one may go ahead with the temperature sensors also, as per the requirement. in case of the modern electric drives. Okay, so when there are the different mechanical drives were there, why one should go ahead with the electric drives? So for the accurate and the continuous control of the speed, position, or the torque of the variable load, the adjustable speed drives are required. The different regions which are responsible for using of the electric drives are to achieve high efficiency. Okay, because the electric drive allows a wide range of power to be used from milliwatts to megawatts at different speeds, and also it reduces the overall cost of the device. Okay, also if you want that the precision control, because in case of the conventional electric drives also, which we have discussed, in that case for controlling one DC motor, it is not possible that to generate a proper DC supply with the help of that DC generator. So that's why there is not that flexibility, and the precise output is also not possible. But here in this case, with the help of the modern electric drives, precise stopping and the reversing of the motor is possible. Like in case of the induction motor, if you think, only by reversing the two phases you can reverse the operation. Means if the conveyor belt, in case of the conveyor belt, if you may think, in that case the reversing operation is mostly required. Okay, also the electric drives provide the protection also for in case of the advanced control, like the changes with the help of level, pressure, or temperature. In that case the electric drives are mostly being used.